Hello, everybody, and welcome to the Decred Assembly, episode 13. Today on the show, we have Charlie Lee from Litecoin. We've got my co-host, Austin Williams, and Dave Collins, who's the lead developer of Decred. Welcome to the show, guys. Thanks for coming on. And today in the show, we're going to be talking about atomic swaps and the big news that we had this past week. Litecoin and Decred had the first atomic swap ever. I think between the two chains. So we've also got tomorrow we actually have another Decred Assembly show. We're going to be meeting with Pamela Morgan to discuss estate planning. And we're also going to be talking about DAOs, which is going to be a really fun episode. So feel free to jump on and join the show if you can. More updates. We have a new vote coming up right now, actually. So if you can upgrade your nodes, and right now we're voting to actually implement all the work that Dave C. Did on Lightning Network, and maybe he can talk some more about that during the show today. And last but not least, anything we talk about in the show is not investment advice, so consult your financial consultants. And yeah, so welcome to the show. How's it going, Charlie?
Good, doing well.
And how's it going, Dave?
Great, thanks. Appreciate being on the show. Thanks for having me.
And just to give you guys a heads up, Austin is he's in San Francisco right now at like a co-working space, sharing Wi-Fi with a bunch of people. So he's not going to be sharing his video, but hopefully his audio.
Yeah, I have terrible internet right now.
So no worries. And I'm actually going to try to pass this off to Austin to kick us off on for everybody new that's not familiar with Decred, I was hoping that Dave could actually do a quick introduction. Maybe Charlie could jump in too to explain kind of what Decred is.
Sure. So really I would say the fundamental principle of Decred is that we really have focused a lot on governance. That's kind of our core proposition at the current time. And the idea there is that we want the stakeholders, the people who actually hold the currency, to be the one who make the decisions as opposed to just the proof of work miners. And most proof of work coins, I'm sure as everybody is aware, it's kind of the miners and the developers who make all the decisions. But in Decred, the way that it works is that the stakeholders actually have all the power through our hybrid system. And through that mechanism, whenever the developers, for example, implement a new feature, such as the one that Tyler mentioned that we're voting on right now, it's the stakeholders who actually make the ultimate decision as to whether or not that particular implementation is accepted and activated on the network versus a centralized group of developers. There are several other features that I think make it exciting, but that's probably the most important one to sort of get us kicked off here.
Yeah. And Dave, do you think you could talk like maybe roughly, or even Charlie, talk about how the process of the staking aspect and that hybrid system works? Short detail, either one.
I can. Do you want to, Charlie, since I already spoke? Nope. Okay.
Nope.
Okay. So right. So the general process is that whenever a new block is produced, it has to have votes from the stakeholders on the previous block that says whether or not that was valid. And you can kind of think of it in a way that you have sort of a second factor authentication layer, where some of the voters that the system is designed such that people buy tickets. These tickets are selected at random, and then those ones that are selected are the ones that actually vote on the validity of the previous block. And through this mechanism, it allows the stakeholders to approve or invalidate the previous block. And that's how the general principle of it works. I can go into more details if you want, but trying to keep it pretty high level there.
Yeah, for sure. Well, thank you for the introduction to Decred, Dave. And so yeah, I guess Austin, I'll pass this one off to you, and maybe you can start us off with one of our first questions regarding the atomic swaps.
Definitely. So Charlie, can you hear me?
Yes.
Oh, good, excellent. Do you mind giving an explanation for the uninitiated? What is a cross-chain atomic swap?
Sure. cross-chain atomic swap basically means that you're swapping 2 coins on 2 different chains. So in this example, we're using Litecoin and Decred. So one person wants to buy Decred with Litecoin that he has, and one person wants to buy Litecoin with the Decred he has, and they agree on a price. And now the question is how to do it in a safe way where neither party can defraud or scam the other person. And previously there wasn't a way, and the only way to do it is to have a trusted third party, maybe create an escrow contract and send the money to the third party, and then have the third party decide when to give the money to the respective parties. So then you have to trust the third person. What atomic swap allows you to do is for 2 people to atomically, by atomically meaning that it either happens or it doesn't. So the coins either change hands or they don't. And when they change hands, one person sends Decred to the second party, and the second party sends Litecoin to the first person. So that's what it means by an atomic cross-chain atomic swap.
That's excellent, and you can separate, I think, the methods by which we do this into 2 very rough categories. And one is like on-chain atomic swaps, and we've also heard a lot about atomic swaps over Lightning or any layer 2 network. Can you talk about the differences?
Yeah. So on-chain atomic swap means that you're just creating transactions on the chain. So specifically for what we've been doing this past couple of weeks is one person creates a transaction to a contract on chain and then the second person also creates a contract, sends coins to a contract on chain on the second chain. And then once that everything is confirmed, then they can pull money from those 2 contracts. So on-chain atomic swaps requires 4 transactions, and it takes time for the transactions to get mined in the blockchain, depending on the speed of the coin that you're swapping. And you obviously have to pay on-chain fees. So if you're swapping Bitcoin, you still have to wait 10 minutes for the first transaction, 10 minutes for the second transaction, or at least 10 minutes, right? So it could take longer for your transactions to mine, and then you have to pay like the fees, depending on what those are. For the other possibility is an off-chain atomic swap. And this is something like using Lightning networks that we've previously talked about, where both parties are running Lightning network nodes on both chains. And actually, yeah, they're running Lightning network nodes on both chains. And then you have Lightning network nodes that expose a exchange rate. So you can go through third-party Lightning network nodes to exchange your Decred to Litecoin or vice versa. And this can, the beauty of the beauty of Lightning network atomic swaps is it can be instantaneous. It can be done instantly. You don't have to wait for transaction confirmation, and potentially it could have lower fees.
That's awesome. And so there's been a lot of talk about cross-chain atomic swaps happening lately, especially on the Twitter's all a buzz about it. And so what was the first of the most recent ones that happened? Was it between it was between Decred and Litecoin, right?
Yeah, so the Decred team worked on the tools to make it very easy to do an atomic swap between 2 chains. And we're testing it out on Decred and Litecoin mainnet. And that was the one that I did using those tools.
So, so Dave, you want to talk a little bit about those tools? Like what makes it possible for this to work? What do 2 cryptocurrencies have to have in order to be able to perform atomic swaps with one another? How does the process work?
Okay, so there are basically 3 main things that that both chains have to have. The first one is some method of conditional execution, and I'll go into some specifics here in a minute. But basically, the reason is that the way that these things work is that you have to make a decision based upon time and whether or not the person actually fulfilled their end of the contract. So first is the branched or conditional execution. The second main thing that you need to have is some way to lock up the funds for some period of time. For example, check lock time verify or check sequence verify. Those are the most common ones among Bitcoin and the similar cryptocurrencies. But it really doesn't have to be those. It's just some mechanism to actually time lock the coins. And then the third one is a shared hash function. And technically, and I think we'll probably go on about this a little bit or talk a little bit about it later on the show. Technically, it doesn't have to be a shared hash function. You basically have to have some way for both sides to prove that revealing the secret will allow the other one to spend. The way that is currently implemented in our tools that we've done is that it's using a hash function. And as a result, you need that shared hash function. So to recap, you need branched execution or conditional execution. You need some way to time lock the coins and a shared hash function. Those are the primary things. And I guess there is one other one. It's kind of obvious, I guess, but you need some way to verify signatures, because otherwise anybody can take the coins. But pretty much any cryptocurrency that deals with sending coins from one person to another must already have that. So it's kind of moot to mention it. So,
so they don't have to have necessarily. Oh, sorry. Go ahead.
Go ahead.
I was just going to say, so do you have to have the same signature scheme, or it doesn't matter as long as there is some?
No, so that's actually one of the really, I think, clever things about the trick is the fact that it doesn't matter what the signature algorithm is, what addressing scheme you're using, everything can be different. This is probably something else I should mention. I've seen it mentioned a lot of times. You don't need SegWit for this to work. You don't need Lightning Network for it to work with the on-chain variant. Like I said, those three things that I mentioned are the only things that you actually need.
Do you need a malleability fix, or will this work on chains that still have malleability, like Bitcoin Cash, for example?
It will work on chains that still have malleability. Now, you might have to actually recreate the transaction because the reference transaction ID will have changed out from under you, but you don't lose the funds, and it can still work, just like you can still deal with malleability on chains that have it with a normal transaction. You can deal with it in the same method. And
then just to preempt some confusion that some people may have, when you say that both chains have to support the same hash function, you're not referring to the proof of work hash function that they may or may not use, right?
Correct. It's a shared hash function within the terms of the contract. So I mean, as a perfect case in point here, Decred uses Blake 256 and Litecoin uses Scrypt. So they're completely different. And we're still able to pull it off because we have a shared hash function that we actually use.
Right, we have a shared hash function. Yeah, right, within the scripting language of each coin. That makes sense.
Yes.
That's interesting. So have you looked at what pairs of coins are compatible? Like currently existing coins, the way they do now. Do you know which coins we can perform these sorts of swaps with already, like right now today?
I'll go over them. I think Charlie might have some ideas too. Pretty much every Bitcoin derived coin will support these because they all use the same scripting language. They pretty much have the same opcodes available, or they can be added relatively easy. The only one so far, or the main one that I've researched that is not easily doable is Monero, and that's because they don't have the three things that I mentioned. They have a different scheme. It's not that it's impossible to do an atomic swap with Monero. It is possible, but using the specific technique and the structure that we have used for these, in this particular instance, it won't work with Monero.
There's another thing is you need a time locking, right? So you need a check sequence verifier, check log time verify. So a lot of the coins have not added those via soft forks. So you won't be able to do it with those.
Correct. So Charlie, this method that the two of you are using now, are there other methods? I've heard of. I'm not sure the differences between these two. I've heard of XCat recently on Twitter, and I think that's what if I'm not mistaken, the Zcash team was using for cross-chain. I've heard of BarterDex and a handful of others. Are they all fundamentally the same method, or are there different approaches to performing these swaps?
I don't know the details about the specific other methods that are using. I would assume they're very similar. Dave, do you know?
Right. So in the case of XCat, I have not looked direct into BarterDex, so I can't comment on that one. But I do know that XCat is using the same structure. Yes. And I think it's worth pointing out here too is that this structure has actually been around for quite some time. I think its first mention was sometime in 2012. So it's not a case of this is brand new so much as the fact that we built the tools out to actually implement the idea and make it easy and make it work, right? So we did all the testing, we built everything, we designed the script and the contracts and worked with Charlie and others to make it a reality. But
Yeah.
the idea has been around for quite some time.
And how long has this been in the works, Dave?
When we first started on it, I think it was about 2 weeks when we decided we were going to do it.
Nice.
That's great. Thanks for doing this. This is a great start. Are there any plans for like a GUI version for the people who are afraid of the command line?
Yeah, so we plan to integrate the Decred side of things into our wallet, Decrediton, and that's going to happen in the future. I know that Charlie probably wants to speak on this a little bit too, because there is another approach that I think that in the long run will probably be better, and that will be having probably a separate program or a separate GUI that everybody can kind of integrate into, and it sort of would work in a multi-cross-chain fashion as opposed to having to download a specific coins wallet. But I think Charlie will probably talk on that because he mentioned it in the last show.
Yeah, so well, I guess you can always have all the coins like add atomic swap capabilities, but the easiest way to do this is to have a UI for the command line tool that you guys built. So just a UI that makes it easy for someone to the UI would talk to the two separate nodes and help do the tongue swap.
Yeah.
Right. So the idea would be
with like a.
Go ahead. I was going to say the idea there would be that, you know, if you have basically you can make an API, and if you have an API that everybody conforms to or that everybody speaks, then you could have that single tool that Charlie talked about, and everybody can just integrate into that.
Yeah, that's great. And then you could so the most basic version of the GUI would just allow you to perform the swaps at whatever exchange rate is agreed upon by the two parties. Do you have any aspirations to handle like automated order booking and matching and stuff like that, like a full-blown distributed exchange, or are you just focusing specifically on the cross-chain atomic swap functionality for now?
Currently, we're just focusing on the on-chain swap, the primitives, to get the ball rolling effectively. Order booking, order matching, and all the order book, that is quite a different beast. You need some method to basically do some off-chain communication and several other things. And also, probably be a good time to go into it. You know, the different, you mentioned it, I believe, early on in the show, the difference between off-chain, or Charlie did, excuse me, between off-chain and on-chain swaps. And so to be clear, on-chain swaps are really much better suited to large OTC trades. And the reason is as Charlie eloquently stated earlier in the show, you have the transactions that are on-chain, and you have to wait for those confirmations to go through. If one confirmation is enough for you, it might only be, say, 10 minutes in Bitcoin, for example. But most of the time, you want to wait for multiple confirmations, specifically if you're dealing with, you know, say, millions of dollars. You don't want to do it with a single confirmation. So you might be waiting up to an hour or longer to get enough confirmations on one side of the chain. And then you have the higher fees as well. So in order for a real distributed exchange to come to pass, this is my personal opinion, is that it really needs to have use Lightning Network or some other type of off-chain mechanisms, a layer 2 mechanism. And the reason for that is you need them to be instant. You need the fees to be lower. I'm pretty sure most traders would shake their head yes when I say that they like things to happen nearly instantly and very quickly, because it makes a big difference in terms of how quickly the rate changes. So really, in my mind, the on-chain swaps are extremely useful, but to be clear, they're not really well suited for distributed exchanges, in my opinion.
Yeah. So do you think that if you had a GUI, easy to use, people could match prices however they see fit, whether it's just bargaining over Twitter or whether it's through some sort of decentralized automated booking thing? So if it were purely on-chain with no layer 2 functionality, do you think they'd be able to compete? Do you think that would be able to compete with current centralized markets? Or do you think it would require like L2 level efficiency in order to compete with?
In my opinion, go ahead, Charlie.
Yeah, it definitely is going to require the off-chain solution where it's instant and to do order books. Otherwise, it's not going to be a very efficient exchange. It's not going to be very user friendly. So, I mean, like Dave said, it's good for large OTC trades. So, if you're on Slack or RSC and you want to do a trade with someone that you've never met before, this is a perfect way to do it safely. Yeah, and other than that, like if you want to compete with like the exchanges like GDAX or Bitstamp, then you really need a different kind of solution, more like instantaneous off-chain cross-chain atomic swaps. But yeah,
Right.
So, and I had a quick question regarding these on-chain atomic swaps. So I know we talked about Zcash a little bit earlier, and we talked about Monero and the difficulty of that. But what happens when you introduce a privacy-centric coin into the mix and you start swapping? Like maybe I swapped a Zcash and then Zcash back, assuming that Zcash is, you know, encrypted and anonymous. How does that lend to, you know, making my transactions back to Bitcoin or whatever more anonymous, or, you know, introducing more fungibility? Anybody who wants to take this?
Yeah. So right. So that's actually a good point, and that is something that can be done. If you have one coin that offers some type of fungibility, some type of privacy enhancements over another coin, you could atomic swap over that coin. You could send your coins through a few transactions on the other chain to allow that chain to work its privacy magic on it, and then you could atomic swap back. That would be a good way to basically remove the link. However, you're still going to have some provenance that you have to deal with, and there are a lot of other caveats there. I mean, if you, for example, if you cross-chain swap X coins, and then 2 days later, X coins
It's the same amount of coins again.
yeah, I mean, you know, it's pretty obvious what happened there, right? So there are a lot of caveats and things that you would have to take into account, but it is a potential solution if you have a coin that doesn't have any type of privacy and want to gain that. You certainly could use it with caveats. You have to be careful.
Well, I think Zcash is kind of faced with this predicament constantly because they kind of have two separate transactions. They have private transactions and transparent transactions. And I think people that, you know, are trying to add more privacy, if they go through a transparent address, they have to be careful about how much amounts they're transferring back and forth between Z addresses and T addresses. So yeah, I think that's a really good point to make.
Yeah.
Austin,
it's hard. It's very difficult to achieve like full-blown anonymity just from the inherent properties of the blockchain itself. There's always these external factors, like are you getting cookies dropped on your web browser while you're purchasing? Are you making a very specific, unique amount disappear and the same amount reappear later? There's a lot to it. As far as atomic swaps, cross chains go, let's just briefly ignore privacy centric coins and are there any privacy concerns inherent in the swapping itself? I've heard, for example, that if I do a cross-chain atomic swap between Decred and Litecoin, that will reveal to passive observers of both chains that which wallets are mine on both chains. Is that the case?
Want to take it, Charlie?
Yeah, well, you would just reveal to the other party which wallets are yours, right? And if someone is actually spying on both chains, they will see that the two transactions or four transactions are linked together, but they wouldn't know who's trading with who. So it's the same as normal Bitcoin, Litecoin, Decred transactions, right?
Okay, so it's pseudonymously. It's linkable, but in a pseudonym level. Okay.
Right. I think another important factor to mention here when we're talking about this linkability is that you almost, I don't want to say you have to know, but it certainly it would make a big difference if you know that if a swap is actually happening between two chains. I mean, right now, if you only have 3 or 4 chains, it may not be that hard, but if this gets much larger and all of a sudden you have 200 different coins and everybody's swapping between all of them, you have to monitor all of those chains in order to figure out which particular swap pair happened. So it gets increasingly more difficult when you throw more coins into the mix. But that is true. They are linkable, as Charlie mentioned.
And so they're linkable. They're linkable, if I'm not mistaken. I don't fully understand the entire privacy picture, but in part they're linkable because the same pre-image is being used on both chains, right?
Correct. So maybe it'll help if I explain the general heart of the trick that happens in these. So the idea is that when the first party sends the coins into a smart contract, And that contract essentially says two things. On the first case, it says, in order to spend these coins, I have to reveal a secret. And that we're just talking about a really large number here, but right, some piece of information, I have to reveal that piece of information, and I have to provide a valid signature. There's the other case of redemption, but I'll leave that out for this point because it's
and the signature is basically the proof that the secret that you're providing works or whatever, right?
No,
Basically.
so the signature is the whenever you normally send coins from one party to another party, you send it to their public address, or their, you guys know you have a general like an L address or a D address, whatever chain you're working on. So when you send it to that address, in order for you to redeem those coins or spend those coins, you have to provide or prove that you have the valid key by signing it. So what we're talking about here is those two pieces of information. You have the secret, you require the secret, and you require that signature, because that way once the secret is revealed, if you didn't require that signature as well, anybody could just take the coins. So you're sending the coins from party A to party B with the two caveats that one, you have to know the secret to spend, and you have to own the address. You have to be the owner of that address. So once that happens, on the other chain, so let's say, for example, let's say Charlie and I were doing a Litecoin to Decred swap here. So Charlie might initiate this by creating one of these Litecoin contracts that send the money to one of my Litecoin addresses. And in order for me to redeem it, though, I need the secret and my private key on the Litecoin chain. Now, on the other side of it, I create a contract as well on the Decred chain that sends Decred to Charlie's Decred address, along with also requiring that exact same secret. Now, I don't know what that secret is yet, and this is where the hash function, the blinding, comes in, and I'll explain that a little bit. But the kind of the principle is that, so when Charlie first creates the contract, he chooses some secret. So he knows the secret. I don't know the secret. But he hashes it, and he puts that hash into the contract. And so now when I create the contract, I also require that whatever secret piece of information is provided, it hashes to the exact same value. And then now that both chains require those hashes to match, they both require that same secret. So once that is done, we both audit each other's contracts and say, yep, you're sending the agreed upon amount of coins to my address. The hashes match. These all look good. Then what happens is because Charlie knows the secret, Charlie goes ahead and redeems his Litecoin. And by doing that, he has to reveal that secret because it was one of the required pieces of information to redeem. And the very act of doing that, now the whole world can see what that original secret was, which means that I can then take that secret and redeem the transaction that was created on the Decred chain. And so that's nice. That's kind of the principle of how that works. Yeah. So if that makes sense, the reason that it provides the link is because the hash of that secret is the exact same value, and it's a unique value. It's a 2 to 256 value from anywhere between 1 to 256. So it's a very unique value. So the chances of you having the same value in two contracts that aren't involved in the same swap, or the universe will die before that happens. Right.
Or the quantum computers take over.
Right. I wonder, so given that this has been talked about since somewhere at least mid-2012, perhaps earlier, I'm wondering why it's not really coming to the fore until now. And I suspect that it has something to do with the availability of check lock time verify and check sequence verify. And I'm wondering what role do those play, and what's difficult about doing cross-chain atomic swaps if we don't have those things? You want to take that one, Charlie?
Yeah. So without a way to lock a coin so that it can't be spent, then you can have the way we're using it right now is to lock up a refund transaction, right? So right now, the reason why you need refund transaction is if the trade doesn't happen, both parties should be able to get their money back without losing it. So the refund transactions are locked for like 48 hours or 24 hours after the contract is created, so that they can't be used until after the contract is expired. Dave, do you want to add more to that?
Sure. So the one of the potential problems, if you were following the process that I just described there, one of the issues you have to think about is like, well, okay, what if Charlie never revealed that secret? So if he were to never reveal that secret, both of us would have our funds locked up into these contracts that neither one of, that we couldn't spend, right? Because he could spend one of them, but I can never redeem it because he never revealed the secret. So you can think of that as defaulting on the contract, right? So because one party didn't live up to their end of the bargain, then the swap doesn't happen. But the problem then is that if you didn't have a way to redeem, to get those funds back, you wouldn't necessarily have been defrauded in the sense that, like, Charlie wouldn't get the funds, but I still would have lost my funds with no way to get them back. So the principle of using the lock time, or check lock time verifier, or check verifier, some method of a timeout, it says that after a certain period of time, I can redeem this transaction regardless of, I don't have to know the secret. I just have to know the private key, but only after, this period of time has elapsed.
Gotcha. And let's say you want to redeem it now, once it's in the contract, you basically have to wait. There's no way to revoke and get the funds back, right?
Correct. You have to have the secret to revoke
Gotcha.
now, or wait for the expiration to revoke without the secret.
Gotcha. And so I think this probably segues into a good topic, Dave, with all the work that you probably just did. So what does check sequence verify?
Okay. The primary differences between, we've both mentioned check lock time verify and check sequence verify multiple times, but realistically the primary difference is that check lock time verify deals with absolute times. So it would say, for example, that if this contract has not been executed by tomorrow at 12 UTC, then that's the point at which you can redeem. What check sequence verify does, though, is it deals with relative lock times. So in other words, if from the moment that this gets funded, X amount of time can pass. So say 12 hours, for example, or whatever. So that's the primary difference, right? So between absolute lock times and relative lock times. And the reason that that's kind of important, that distinction is that for these regular type of on-chain swaps that we're dealing with now, it doesn't make much of a difference because the time decorrelation is pretty close, right? We both agreed, we're both going to make the swap. We're probably going to do it within an hour or two of each other. Yeah, if having an absolute lock time isn't that big of a deal. However, when you start to talk about Lightning Network and off-chain, it really makes a big difference now, because if you can think of it this way, I probably should talk a little bit about this so it makes sense, but in the off-chain world, you don't actually send the transactions to the on-chain until a certain point into the future. And so what is really kind of going on in the meantime is that all of these transactions are being sent back and forth to each other off-chain, but they're all valid transactions, and at any point, though, they can be sent and broadcast out to the network in order to do what's called closing the channel, or effectively to ratify it. So the problem there, if you can imagine it, is that in the off-chain world, because those transactions are created and not sent to the real chain for potentially months, weeks, whenever, then having an absolute lock time really kind of is not efficient, because of the fact that as you're approaching that lock time, you would have to send a new or create a whole new contract and create a whole new transaction to avoid the other party being able to revoke those funds before they should be. With the relative one, though, it's great, because until that transaction is actually sent to on-chain, it's actually put into the blockchain, that timer doesn't start because it's relative. And that's why they're much better, or really a lot more efficient when you start to talk about off-chain atomic swaps.
Gotcha. So maybe you could talk a little bit about the work that you did, because like I mentioned in the beginning of the show, we actually have a vote right now on the Decred network. So again, everybody upgrade your nodes. That goes for the mining pools and staking pools too. But we're actually voting to integrate, I think, check sequence verify. Is there any other additional work you had to do to make Lightning Network enabled on Decred?
The primary one was the check sequence verify, but we're also having a vote on Op SHA-256, and that is pretty much what it sounds like. Remember earlier we talked about having these shared hash functions. Well, because Decred is based on Blake, we actually replaced that opcode with the Blake opcode, so we didn't have the SHA-256 opcode anymore. And the kind of the expectation is that we're able to do these on-chain swaps by using a different shared hash algorithm that we happen to share. It's actually called RIPE MD160, but kind of in the future, the idea, and pretty much everybody has kind of agreed, that SHA-256 is kind of going to be the standard between the cross-chain swaps, so that every chain that implements SHA-256 will be able to participate in these swaps. And so that's why we're having that vote to be able to implement the SHA-256 opcode. So in the future, we can continue to work with all the different chains. Gotcha. And then check sequence verify, like I mentioned, are those relative lock times, and that's really not just for atomic swaps, but they're really kind of required for Lightning Network for essentially the same reason. It's not directly for the atomic swaps, but it all has to do with the fact that you need to be able to have timeouts in a relative fashion, such that the time doesn't start to tick until the transaction actually gets broadcast to on-chain.
Mm-hmm.
Gotcha. And then with Lightning Network, like still, whatever coin wants to do these cross-chain atomic swaps is going to, like you said, going to need these shared hash functions. So
correct. Yep.
Gotcha. That's awesome. Yeah, Austin. I think Austin had to step away, but I'm sure he's probably has more.
Back now. Sorry about that. Yeah. And what about are there any race conditions we need to be aware of? Like, if can I steal your money, for example, if we're in the middle of a cross-chain swap and I keep you offline somehow through DDoS attack, or I just in a closet or something, or is that not an issue because of check lock time verify, etc.?
Go ahead, Charlie. I can answer it, but I spoke for a while there.
So with the lock time, basically it's staggered, where the first contract, I mean, you can decide how long before you can do the redeem, right? It's a matter of security versus like convenience, right? So the first contract, I think the Decred tool is set to 48 hours for 2 days, and the second contract is set for 24 hours. So after the party A takes his coins, party B has about at least 12 hours to take his coins, I believe. Dave can probably be specific about it. So
yeah,
you do have some time. Yeah, or additional 24 hours. Yeah, so you do have some time to make sure that you get your coins also. But if you forget to take your side of the coins, then it's up for grabs. So there's definitely some risk. But it's the
I wonder if
the coins help.
Yeah, definitely. So so you'd have to keep me offline for, well, in the example you gave, you'd have to keep me offline for 12 hours in order to steal my coins.
Or if you
which would be quite a task. Yeah.
If you can convince all the miners to not mine your transaction in
for a full day, 24 hours.
Yeah. I mean, there's definitely an attack vector, right? Like anything else, there is.
Sure.
And what are the attack vectors when you implement Lightning Network on top of this? Is it so then the risk only becomes when you broadcast the transaction to the network? Is that where the
Lightning Network has its own like attack surface? I don't know the full details. Probably worth a full podcast on this too. So there's if the transaction, if the network is jammed and there's not a lot of block space, then potentially there's an attack vector where you can prevent someone from closing their channel, and then you can steal the funds. I don't know how big of a attack surface that is, but that's probably more for the Lightning Network teams to explain how like the whole deal with that.
Yeah, maybe Dave might have some insight on that.
Yeah, it's like Charlie said, that's probably an entire show, pretty in depth. But I think basically what Charlie said is certainly the case, that the real, I guess, major sort of, or the biggest attack vector, the most obvious attack vector, is that if you can prevent the transaction from being broadcast to the network, then it will never do. However, I do want to point out that this is another reason why those relative lock times, that check sequence verify, is so important, is because it is a much bigger problem if you're dealing with an absolute lock time. So if you have an absolute lock time that says that this thing can be redeemed by the original party by tomorrow at noon, And if I can prevent your transaction from being broadcast until that point, then I can steal the funds. However, if you're using the relative lock times, which I can check sequence verify, it doesn't matter how long you delay the transaction. You can just annoy me because eventually it's going to go. And once it actually gets on chain, from that point that it actually gets mined, I then have the 24 hours. So that actually really kind of solves, not necessarily solves, but it really mitigates that particular attack vector.
Gotcha.
Yeah, that's fantastic.
And I actually had, there's obviously a lot of debate in Bitcoin, especially with integrating Lightning Network, because a lot of people think, hey, this is, the scaling solution here. I was wondering what your thoughts are, because if you're doing a lot of Lightning transactions and you're not just actually using the Lightning Network, you can actually generate a lot more transactions on chain because if you're opening a channel to participate and then you're closing a channel to transfer funds. So I mean, until we have like everybody on Lightning Network or some form of Lightning Network, I mean, this could essentially lend itself to being more of a scaling issue. Do you guys what do you guys think about that? Maybe Charlie could talk on that.
What's the concern again?
So you're opening a channel and you're closing a channel, and that requires 2 transactions. Like let's say I'm just participating in the Lightning Network for a little bit, and then I'm closing my channel. So I had to create 2 transactions to.
Well, you wouldn't need to close your channels, right? So to participate with the Lightning Network, you have to have a payment channel open with one party that's part of the Lightning Network. Once you're connected to the whole network, right? So you open a transaction, you open a channel, and I believe you can have that channel open indefinitely. So you basically put however much money you want in that channel that you want to spend and receive, right, for small transactions, and you can keep using that channel. Right? You don't need to close it. It's kind of just like an account open. It's like a checking account. You put money there, and you can use a debit card to buy stuff.
Sure. And I guess my point was, let's say the person I need to send the money to now, I have all my money on Lightning Network. I mean, like maybe new people getting into Bitcoin, they just have like $20 or whatever. They put it on Lightning Network, and now they need to, give somebody funds who's not on Lightning Network. Obviously, the smarter thing to do would be like, hey, man, join the Lightning Network, and it'll basically be free. But, let's just assume maybe they're a merchant or somebody like that hasn't integrated. This is where I could see the concern of on-chain transactions kind of increasing if this were to happen more than not. But I don't know.
Yeah, I guess we won't really know until people start using it, right?
Yeah.
This is all theoretical because this has never existed. So.
And will there be more than one Lightning Network, or will it just kind of be a ubiquitous thing that?
That's probably more of a political question as opposed to a technical one, I think. But so one thing I did want to add, when we're talking about the opening and closing of channels. Personally, I mean, of course, that's one of those thought experiments, right, where you can say like, oh, but this could happen. But if we look at it realistically, let's look at it like, well, why would you, if I wanted to send a Lightning Network transaction, right? Why would I want to do that? Well, I probably want to do it because I want low fees and instant transactions. That's my goal. Well, if I don't already have a channel open, I can't do that. I have to wait for the channel to be open, which means I have to wait for the on-chain transaction to go through. And then if I want to close the channel, guess what? I have to wait for that to happen too. So I went from wanting to do something instantly and cheaply to doing something that takes twice as long as just a regular on-chain transaction would have been and paid twice as much for it. So, you're disincentivized from doing that. Like, so is it a possibility? Sure. Will it happen? I highly doubt it, because it just, it doesn't make sense. What user is purposely going to pay twice as many funds or twice as many fees and wait twice as long to stick it to the network? I guess, I don't know. Sure. It doesn't make sense, right?
But let's say we have 2 different like Lightning wallets. Like we have I have A Lightning wallet and B Lightning wallet, and for whatever reason they are not connected. Like I don't know. What do you guys think?
The multiple Bitcoin, like when the Lightning teams have agreed to work on the same protocol, so those
Gotcha.
interoperable. there are a few other teams that are working on incompatible protocols. So potentially, if those are both successful, then you have multiple Lightning networks that don't talk to each other. And I assume one of them would win out with DT network effects, right?
Yeah.
But there's also going to be different Lightning networks on different coins, right? Litecoin will have its own Lightning network. Bitcoin has its own, Decred has its own. So there's going to be multiple networks running. And ideally, they all talk to each other and be able to transact in between them.
Gotcha.
Yeah, and I think Dave's point's valid, and people with those concerns won't use it for all the reasons that you described. But the ones who will be the people for whom the savings on the amortized cost of those small transactions are worthwhile. And I think it really remains to be seen. And that's part of the exciting part about this experiment is that we don't know how many people are going to benefit from those amortized costs of using the Lightning Network and how many won't. So it's really an experiment to see like how much it takes off. It's pretty
also, the vast majority of crypto users today are using online services like Coinbase or Zappo. So for those users, if Coinbase has like a Lightning Network node that talks to the Lightning Network, then they can take advantage of all the benefits of Lightning Network without having to create their own on-chain transaction to the network because they're already off-chain.
Yeah.
So.
Yeah. Just to bring it back to. Oh, go ahead.
I was going to say that's probably a key point too. Is that I think that it's kind of important to keep in mind here is that the construction of the way that the Lightning Network works is that you don't have to directly communicate with the recipient, right? You have a whole bunch of nodes in between there, and this is all done in a safe method. So as Charlie mentioned, if you have large players like Coinbase, maybe later in the future, maybe you have Amazon, you have these really big players, pretty much everybody has an Amazon account. So if you have an Amazon account or you have a payment channel open with Amazon, and then Amazon had one open, say, with Coinbase, and then the person that you want to transact with had one open with either Amazon or Coinbase, it will find a route and it will be able to actually complete that. So a lot of the concerns that I've read about that, I think are kind of moot because of the fact that, that you are going to have these centralized services. That doesn't mean Lightning Network is going to be centralized. Don't misread that. It just means that you are going to have these large spokes, these large companies. It's sort of inevitable. You have these large corporations, and if they're participating in the Lightning Network, it kind of solves the vast majority of those concerns.
Yeah, because these hubs, they can have as many channels open as they want, and then you can, you might be forced to actually route through them. So.
Yeah, it's very interesting. It's very similar to the topology of the internet. It would be very difficult to have two distinct, separate internets. All it takes is one link between them, and then you have one internet again. The topology is pretty robust.
Yeah,
correct.
So Dave, I wanted to, maybe you could touch on this, but I know there's been a lot of talk about adding privacy via Lightning Network to coins. Maybe you could, briefly touch on some ways that you can actually add some more fungibility to a currency via Lightning Network, maybe.
Well, sure. I mean, I think one of the, I won't go too much into detail here, but I think one of the sort of obvious things is that if you can prevent the transaction from ever making it on chain, then obviously
there's no proof.
Right, exactly. I mean, if somebody is out there passively monitoring it, sure, they might have seen it, but that's kind of like one of the major benefits that you can get is that I think you can probably liken it to, there are some more advanced techniques that I'll go into a little bit. I don't want to go too much in detail, but kind of the idea is that if you think of it in terms of math in the sense that if I have A plus B, and then if I multiply that by 2 on one side, or on both sides really, then I don't change anything, right? You have this property. So the way that this works is that in the math and the cryptography, you can actually do some tricks like this where you don't actually change the end result by changing the terms. And by doing this, you can sort of add a whole bunch of things together and subtract a whole bunch of things and do it on both sides of the equation. And the end result is provable that it came out to the same result, but you don't know what every individual term was. I know that's a little bit high level and maybe slightly convoluted to follow, but because I don't want to get too heavy into the math, but that's kind of the principle there, is that you can effectively do like a cut through where you see the start state and you see the end state, but you can't prove what happened in between. Well, you can prove it, but you can't see what happened in between those.
Yeah, exactly, and that's really the heart of the Mimblewimble design, is to cut throughs both on the transaction level and also at the entire blockchain level. It's brilliant. It really is. Yeah,
and so basically, if you're not tied to if you're not tied to the rules of any given chain or whatever, you're open to do pretty much anything you want.
So I want to, if we can, bring it back to atomic swaps just for a minute. And first of all, just say thank you both for working on this. It's fantastic to see this stuff actually materialize and become real, and not just be a shower thought in 2012. I appreciate that. Let's maybe just take a moment. I'd like to hear what for both of you, what your vision is. Like, this is the first step towards something, and I'm wondering what the something is. In 10 years from now, what has this moved us closer to? What's the ideal that we're moving towards?
Well, the vision I have is that in 10 years from now, people will be using money, not caring the underlying network, right? Similar to how people use the internet right now, and they don't care that how the packets get to them, whether it's TCP/IP, UDP, or any other protocol. So today, like when I'm using Bitcoin or Litecoin, like we're like early adopters, so we know exactly what's going on. Like most of us know like what happens when you send Bitcoin transactions, right? How it gets validated, how it gets verified, and what happens with the whole network. So 10 years from now, when people are using Bitcoin, Litecoin, or Decred, or any other cryptocurrencies, I think they wouldn't know. They're just like swiping a card or doing something, right? Putting their thumb to something and paying. And something would just happen in the background, whether it's like sending Bitcoin, whether it's Bitcoin converting to Litecoin, atomic swap, using atomic swap, or whatever. So it just happens. So atomic swap is kind of something that really makes everything that much more powerful by combining the different networks so that they can all interoperate, right? So right now, like you're holding Ether to power some decentralized apps, but in the future, you don't have to. You can hold Bitcoin or Litecoin, or whatever, and it would just convert automatically to Ether when you need to use it. The example I like to give is right now you drive a car, but you don't have barrels of gasoline in your house in case your car runs out of gas. You go to a gas station and use your dollar to buy gas and put in your car when you need to, right? You don't have to speculate or just hold a large amount of something that you may need to use in the future, when you can easily convert between the different currencies or commodities or whatever you want to call them. So I think atomic swap just brings about the ability to get to the vision I envision.
So more interoperability.
Yeah.
And Dave, what are your thoughts on?
I was going to say I agree with Charlie. I think getting that interoperability is key. I think another part of it, I mean, of course, that's kind of the end result, is getting that interoperability. But one of the things that I'm most excited about it is the fact that I'm pretty big on trustless systems. We removing the intermediaries and removing the trusted third parties. And one of the really incredible things I think here is the fact that these allow you to do something that is impossible to do with fiat. There's really no way that you can, for example, change US dollars and euros without a trusted third-party intermediary. It's just impossible. Whereas in the crypto world, especially with these on-chain and even later on off-chain swaps, that is really going to open the door for so many more things. The end vision, of course, is like Charlie said. I think that's an excellent one, and I'd love to see that to pass too. But I think that primitive that allows you to do something that is completely impossible in the world of fiat is really powerful.
Wow, that's awesome. That's awesome. Yeah, Austin, do you have any final thoughts on this?
No, that's it. I just want to say thanks again for making it real. It's people have been talking about it. Building these tools is great. I hope you keep working on it. I know that I think it's Ideal Collab has some there's grant money somewhere so that the collab division of that's like their R&D division of IDEO, the top design firm in the U.S., to help out in the cryptocurrency space. And I think it might be specifically related to UI design or UX design. So if you're interested in some UX help, possibly for free, I would encourage you to look towards them. I know that there are a handful of groups taking them up on that. I hope to see more of this in the future. And again, thank you both. This is really cool move forward.
Yeah. Thank you so much for coming on the show, guys. And thank you to all of our viewers out there for joining in on the show. Hopefully we gave you some cool tidbits of information to scratch your heads on. So, all right, everybody. Say bye, Charlie. Say bye, Dave.
Thanks. Take it easy.
Take care.